Okay, so our next lesson is going to be on parallelogram measurements. We are going to use the 4 theorems of parallelograms, so you want to get those notes out as well. So this is our image, and why don't you take a second to write down this image, noticing all the different marks on it. Pause your computer to do that. And then what we're going to do is we're going to solve for all of these things over here. So we're going to solve for x. So I see an x here, 3x plus 2. That is on a diagonal. We have an 11 on the other side of the diagonal. We also have a 4x plus 2 over here. That's on a side. So what we can do is we can set up an equation. So the 3x plus 2 and the 11, we know that diagonals bisect each other, which means they cut them in half. So in order to solve for x, we set up the equation 3x plus 2 equals 11. And then we would subtract 2 from both sides, and you would get 3x equals 9. And then you would divide by 3, so you would get x equals 3. In order to solve for y, we want to find out where y is. So if you follow my cursor, we have 4y minus 4 down here on this side, and opposite sides are congruent. So we have a 28 on side AB. So the equation that we could set up here is 4y minus 4 equals 28. And then when you solve for y, you would add 4 to both sides, you get 32. And then 4y equals 32. And then you divide by 4, you would get y equals 8. And then we're going to solve for the variable of m. So we got to find m. Oh, m again is right here. M is on the other diagonal. So we have 2m plus 1 here. And then we have 15 on the other side. So the equation we could set up here is 2m plus 1 equals 15. And then you would subtract 1, and then you'd get 2m equals 14, m equals 7. And then what we need to do is we need to go back and figure out some of these lengths. So BC is right here. We know that its measurement is 4x plus 2, and we already solved for x, where it's at x equals 3. So we just have to substitute the 3 in for our x. And then you get 4 times 3 would be 12, plus 2 would be 14. So BC would be 14. For AC, we got the whole thing here. Well, we know that half of it is 11. So we could just double it and make it 22. And then BD, again, BD diagonal. Diagonals bisect each other. We have 15 here. So we would just have to 15 times 2, which would be 30. So that's one way that you could use a picture that has a lot of different parts and pieces moving on. And we're going to get into that next one right now with a little bit more challenging stuff. So we have this parallelogram, and we're going to go A, B, C, D, and we've got a 12 here. So we know that AD is 12. We've got a 10 here. So I'm going to say that EC here is 10. I've got this angle right here, that angle A is 60 degrees, or angle BAC, because it looks like over here our angles are all written with 3 letters. And then we've got CD over here, CD as, or DC as 11. And then we have this angle measurement up here. See how the 45 is only in this top part? So what that means is angle CBD or DBC is 45 degrees. If it's written like this, where it has an arc going through the whole thing, that means the total measurement is 60 degrees. All right, so let's get started on this one. We have AB. AB is a side right here. And we know that opposite sides are congruent. So my 11, AB is 11. For AC, we have AC as the whole diagonal. And we just talked about this number 10 here being EC. So we know that diagonals bisect each other. So it would be 10 times 2, which would be 20. We have the measurement of BCD. BCD, this big angle up here. Well, we know that theorem 2 says opposite angles are congruent. So let's look opposite here, and it is 60. So that would be 60 degrees. Angle ADB right here. is this piece where my cursor is. This is a tricky one, but one thing that we do have to remember is that it is a parallelogram. So these lines right here are parallels. And then we have a diagonal going through, and the diagonal, if we were to continue it, it's just a transversal. So if you remember the alternate interior angles, alternate opposite sides, and then on the interior, so 45 degrees up here would be 45 degrees down here, because they're alternate interior angles with the parallel lines and transversals. For CDA, another angle, what we do have is it's the whole angle. So these two parts, and again, I'm going to go back to theorem, I believe it's theorem 3, where it says adjacent angles are supplementary. So we have 60 degrees here, and it is supplementary with this one, which means they add up to 180. So this one should be 120. And then BDA actually is the same as ADB. So we already got that answer right up here, and that would be 45 degrees. Okay. For the next one, what I want you to do is I want you to pause your computer and try and come up with these angle measurements. And then I'm going to put them into these questions into a quiz that you'll be able to do right after you take these. Again, I would go back and listen to what I said and watch it again. And if you have any questions, refer back to your parallel lines and transversal notes, but those alternate interior angles are still there. Okay, have a good one and have fun with these challenging parallelograms.